Okay, in 3.1 you learned about the quadratic equation, or the quadratic function f of x equals ax squared plus bx plus c. And then you also learned that if a is greater than 0, your graph opens upwards, and if it's less than 0, it opens downwards. So if it opens upwards, that means this very bottom value, that is called your minimum. And if it opens downwards, this top value is called your maximum. So today we're going to focus on finding min and max. So to find your vertex, we did x equals negative b over 2a, and then we substituted that x in to find my y coordinate. Well, in order to find min and max, we use the exact same steps. So your vertex is actually your minimum or your maximum. So let's start with our first example. So consider the quadratic function f of x equals negative 3x squared plus 6x minus 13. So let's see if it has a minimum or a maximum. So here negative 3 is A, 6 is B, negative 13 is C. So A is negative 3. So since A is less than 0, that means it's going to open downwards. Which means it's going to have a maximum value. So since it opens downwards, that means this top right here where the vertex would be, that is your maximum value. So now we're going to find that min or max. Exact same way as 3.1 where we have to do x equals negative b over 2a. So here it's going to be x equals negative 6 over 2 times negative 3. Well, 2 times negative 3 is just negative 6. Negative 6 divided by negative 6 would be 1. So I got my x value, and now I'm going to do f of 1 to figure out what my y value is. So I plug in 1 to any x I see. So it's negative 3 times 1 squared plus 6 times 1 minus 13. So 1 squared is just 1, so 1 times negative 3 is negative 3. 6 times 1 is 6 minus 13. So negative 3 plus 6 minus 13 would give me a value of negative 10, which means my max is 1, negative 10. And that's also my vertex too. So it kind of doubles up as 2 bits of information. So step C now is to graph this function and determine the domain and range. So in 3.1 you learned how to graph. So right now you're going to try graphing. While you're doing that, I'm going to talk a little bit. So if you notice, the max is 1, negative 10. So if I go to 1, negative 10, it's here. From step A, we saw that it opened downward. Well, if it's opening downward, it's not crossing the x-axis, which means there's no x-intercepts. So actually, you only have to find y-intercepts right now. Remember, to find y, you're plugging in 0 into your x value. When you do that and simplify, we're going to get negative 13. That means it crosses the y-axis at 0, negative 13. So I came over here and plot. It would be around there, and then my graph would look like this. Now, whenever we're doing a parabola, unless it says otherwise, your domain is always all real numbers. So if you notice, this can go all the way down to the left and it goes all the way down to the right, which means my domain can go all the way to negative infinity and it can go all the way to infinity. My range is the only thing that's going to change. So if I take my pencil and I put it on my graph, I notice that it goes past negative 10, which means it can start at negative infinity. Now I take my pencil and I'm moving it up, and wherever my pencil stops touching this graph is where I stop my domain. So the last top point is negative 10. And that is included because it's part of the vertex. So notice how my vertex or max value was negative 10 and my domain ends at negative 10. So let's try another one. So using the function, we're going to find the min and max, and then we're going to find the domain and range. So your a value here is 4, which means a is greater than 0, so it's going to open upward, which means it's going to have a min. So to find min, we do the exact same thing as we did yesterday when we found our vertex. So we're going to do x equals negative b over 2a. So x equals negative 16 over 2 times 4. So negative times a negative is just positive, so it's 16 divided by 8, which gives me 2. So now I have to plug in 2 into my function. So I get 4 times 2 squared minus 16 times 2 plus 1,000. So 4 times 2 squared would give me 16 minus 32 plus 1,000, which means my y value is going to be 984. So my minimum value is 984. If I wanted to sketch this, 984 would be here, and I know it opens upwards, so it's going to look like that. So again, it's not going to cross that x-axis. So now I have to figure out the domain and range. So like I said, domain for these graphs are always all real numbers. And then your range, you're looking at your min or your max value. So range is your y values, which means I'm going to start at 984 because it's a min and it's going up towards infinity. So that's how you figure out your domain and range, and then your min and max. So next we're going to talk about leading coefficient tests. So the leading coefficient test, it's talking about end behavior. So eventually your graph is going to fall or rise depending on the coefficient and the degree. So if your leading coefficient is odd, or the degree is odd, what we do is there's two cases. So the first case is if the leading coefficient is positive, the graph's going to fall to the left and rise to the right. If the leading coefficient is negative, the graph's going to rise to the left and then fall to the right. If your degree is even, it rises, and the coefficient is positive, it rises both ways. And then if your degree is, or if your degree is even and then your coefficient is negative, then it's going to fall both ways. So what I mean by odd is, let's say we had like x to the third plus 2x squared minus 1. So this leading degree would be odd. Even just means if I had like x squared minus 1. So this leading degree is an even number. So those are the four cases. So we're going to go through 3 examples and we're going to determine what happens to these graphs. So starting with example number 1, we're going to use the leading coefficient test to determine the end behavior of the function f of x equals x cubed plus 3x squared minus x minus 3. So if I look, we're looking at the greatest degree. So the greatest degree is 3. We say that this has a degree of 3. Well, 3 is an odd number. So it's taking me back to my odds. Now I look at the leading coefficient. So right here, leading coefficient is just 1. Is 1 a positive number or a negative number? It's a positive number. So I have an odd function with a positive, which means it's going to fall left and then rise to the right. And that's all we're looking for. So you have to notice the degree, the leading coefficient, and then what it does. Now here's another function. Determine the end behavior of the graph of g of x equals negative 4x cubed times x minus 1 squared times x plus 5. So notice this is not in standard form. So what we could is we could expand it, but that takes a lot of time and effort. So here's a fast way. What we do is we look at all the degrees. So if they're being multiplied, this is what you have to do unless you want to expand it. So I have a degree of 3, I have a degree of 2, and then this has a degree of 1. So it's a little imaginary, don't forget it's there. What we do is we add all 3 together. That means this whole function has a degree of 6. So since it has a degree of 6, it's actually an even function. So if they're if your components are being multiplied, you have to go off the degrees and add them. Unlike this first example where we're adding those terms. So that's the only difference. So it has a degree of 6. Then we take a look at the leading coefficient. So we're taking a look at this number right here. Well, the leading coefficient is -4. So that is a negative number. So now we have to think of, well, what happens when I have an even function that's a negative number? And the answer is that it's going to fall both left and right. So your function's going to look something like here, and then we don't know what's happening in the middle, but it ends up like this. Okay, last one. So we're going to find the end behavior of f of x equals -49x cubed plus 806x squared plus 2,503. So first we look at the degree. So since they're adding, I just have to look at that first degree. So the degree is 3, which means the function is odd. So now I take a look at the leading coefficient. So the leading coefficient here is -49, which means it's a negative number. So now I'm looking at, well, what happens when my function is odd and I have a negative degree? And the answer is it rises left and falls right. So the rest of this I want you to try right now, and it's the practice couple pages, remembering that we talked about min and max day and how to graph those functions based off that, and then we talked about leading coefficient and also domain and range. So try the next problems and then submit it and then move on to the next video.